Hey everybody, this is Larry. This is day 21st of the May Leetcode Daily Challenge. End of 3 weeks. Yay. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about today's problem. Find and replace pattern. So I usually start these live, so it's a little bit slow. Let me know, I'm going as fast as I can. So, skip ahead and watch it on 2x, whatever you need to do to kind of whatever you do. This is the beauty of a video or technology. Excuse me. I am recording these live, so yeah. Okay, given a list of string words and pattern. Okay, return a list of words that we in pattern. Okay. Where's APP? Oh, okay. Okay, so basically, it matches the pattern if there's a one-to-one relationship between the characters. Each word length is going to be 50, but it doesn't. It almost doesn't even matter. We could do it like roughly. On the order of the alphabet, so it should be okay. Maybe. Yeah. Yeah. So I think doing it naively, given these constraints, doing it naively should be good enough. You can do, and I'm going to do some pre-processing because we have only one pattern, but I think that should be good. And so my idea here, and my first thought, and probably the thought that I'm going to go with, unless something goes tragically wrong, is just abusing the frequency map. So we can do something like this. So, and because the pattern is non-changing, we can actually compile the pattern. Oh wait, does it have to be in the same order? Maybe that's the part that okay, so it has to be in the same order. So with the frequency, okay, so I was wrong about it for a second because I think I read permutation, but then I misunderstood a little bit. But yeah, it has to have the same pattern, so it has to be 1-to-1. So we can do it just naively. Maybe we could pre-compile things, but I don't even think it's necessary given these constraints because each pattern is 20, and each length has 20, so you can do some 20 square, n square type thing where n is the number of characters, and that should be good enough. So let's do it. Let's just write a fit function for now. We'll do it one at a time. And then, the other one is just a for loop, so it should be good. So word and a pattern. How do we want to do this, right? So we assume that these two already have the same length because they tell you that. Oops, keep doing that. So okay, so we need a lookup and a reverse lookup. Okay, so let's see. If x in lookup, well, if let's see, I'm trying to think about my conditions in a way that is just concise. So basically what this is going to be false if and lookup of x is not equal to y, return false. Also if y is in reverse lookup and reverse lookup of y is not x, then return false. Otherwise, lookup of x is equal to y, lookup of y is equal to x. So I do take some time to think sometimes, and then when I type it out, I just type it out, and that depends on the problem, of course, and what edge cases come up. But yeah, and then return true otherwise. So I'm trying to think whether I think this should be good, maybe not. This is a little greedy. I think the thing that I'm thinking about is whether you can accidentally have something map to two things, but I think the reverse lookup fixes from that. So so yeah. So then now we just go return word for word in pad words if fit. Well, maybe this is match. Let's find a better word. And that's pretty much it. Convert it to lists. Well, the idea, this is pretty much it. Whether this is correct or not is another story. Okay. I should have just copied and paste. Ooh. Oh. Looks okay, so let's give it a quick submit. Cool. I know that earlier I said that n squared for this function is okay. I'm just saying that in the worst case, I think at the time I wasn't quite sure that what I wrote here is correct off my head. But given that the constraint is only 20, I'm just saying that like even if you do something like really silly, it'll be okay, right? That's what I was going at. Not that this is the goal of my complexity. It turns out that of course, if you look at this, and assuming constant lookup on hash tables, then well, this is okay. I mean, I use the hash table, but you could actually use because you could use like an array of 26 characters or something to the order of the alphabet, the size of the alphabet. But in any case, this is going to be O of n, where n is the number of characters, and this is going to be linear in total in the size of the input, because for every word we look at it once, and for pattern we look at it m times, where m is the number of words. So this is linear in the size of the input, and in terms of space, in the worst case, this is going to be linear space, just because. Well, okay, depending on how you want to. I mean, you can maybe put it in a better way, but this list can be linear, so that's why it could be in linear space. But this function, of course, just takes O of one space, quote unquote, or O of alpha space, where alpha is the size of the alphabet, or U, depending on whatever, the size of the universe. Because basically all we do is just look at character at a time and have a alphabet lookup. But this one will take extra linear space. But that's all I have for this one. I think this is just trying to figure out this bijection thing by having a lookup and a reverse lookup. I think probably I've done this before. I jumped to this really quickly, I think, but without honestly proving it super concretely. I probably have. I haven't done this particular problem per se, or maybe I have actually. I don't even remember. I don't remember doing it, but this kind of thing does happen a bit, where there's a bijection from A to B, and you kind of mash them, and then you just have to make sure that like if you kind of visualize it, you have a left thing, a function, and a right function, and you want to make sure that is 1-to-1 on both sides, and that's why I with that visualization, that's why I made this implementation and was like relatively okay about confidence. But lately I've been sloppy with the confidence. That's why I'm a little bit less confident than usual. But that doesn't that's not because I don't know this, I don't think. But yeah, that's, I don't know. I don't think I could do much better. So let me know what you think. I will see you later. Have a great weekend and stay cool, stay good. To good mental health. Bye bye.